Next on my tiny bench is this beautiful Adcom GCD-750. Owner's complaint is that it seems to play but has no audio output. First thing, of course, let's verify the symptom. Yeah, use the manual moving of the camera. Yeah, sure enough. Looks to me like no output to speak of. Okay, next, pull the cover, take a top-down look, see if there's anything obvious. Be right back. Here we are back for a top-down view. Beautiful board. So we've got power supply over here, analog left, analog right, as full balanced. The two DAC chips, balanced output, unbalanced output, digital section, and then transport over here. Let's just give her another whirl. Power on. Play. And still nothing on the outputs. Let's see. These are muting relays. Yep, nothing. But information on the front panel is advancing. Certainly gives the impression that it's playing. Other than the fact that there's no sound coming out. I'm going to take a quick look at the schematic and find a test point or two. What we need to do is we need to determine, isolate. Is the problem in the audio output or is the problem in the switching? Be right back. So having determined that there is in fact no audio out, one of the first things I want to take a look at is the muting circuit. It's obvious culprit. Generally, muting circuit in this particular CD player is a couple of relays. That's odd, and there are two relays. It isn't one relay that feeds both channels. There are two relays. So it would be odd for it to be in the muting channel and affect both sides. You're more likely to see it on one side. But nonetheless, there are some commonalities, so it's always a good place to start. And if you see, the audio comes in, audio comes in the wrong spot here from sheet 4. And sheet 4 shows us over here that this is audio out to the relay section. And basically, here's your DAC. Here's the current out of the DAC, and this section converts the current to a voltage. Voltage is further amplified and filtered here. This is a digital filter and an IV converter that goes to that muting section we were just at. So obviously we should have audio on R411, both sides. I mean, it's a resistor, so you'd expect this side to be a little bigger than this side. But we didn't have any audio there. So that leads me to think the problem is not in the audio section, but long before the audio section. And in this particular CD player, it's a little sophisticated, but they have a switching circuit here, because if you'll recall, the GCD-750 allows you to run a digital in, so it can serve, the unit itself can serve as a DAC for an external signal, or as a CD player for the transport that's built right in. Well, this switching system over here is involved in determining which of those two data inputs is fed through to the digital signal, digital section. So I started probing around there a little bit, and I noticed something here. Actually, I noticed it over here first. Some of these values were a little lower than I was expecting. Now these are interesting op amps in that they've got an input and then they've got two outputs, plus swing and the negative swing outputs, but they also have an enable. That's what pin 4 is here. So when pin 4 is high, signal passes through. If pin 4 is not high, signal is trapped. When I measured pin 4 here, it was about 1.2 volts. We would certainly expect it to be closer to 5, somewhere, usually 3.4, 3.5 is enough to trigger 5 volt high signal. So we trace it back, trace it back, trace it back, trace it back, and lo and behold, we've got a regulator over here whose job is to convert the plus 12 volt DC to 5. And this is one of the mini regulators that's about the size of a transistor. It's not the big flat type that typically mount to a heatsink. So we've got the good 12 here, but here it's about 1.4 instead of the 5 we would expect. Now that really means a couple of things could be at fault. One, the most obvious, is the regulator's bad. But tearing this board out, getting to the bottom, and going through everything that's required to replace that, it's probably a good idea to make sure that that's what we think the culprit is before we move forward. So, as I say, we see 1.4 volts here, so that tells us it's not a direct short to ground. Now this is a tant, so I think if it were gone bad, it would either gone open or gone short, so then we would see 0 here. We wouldn't see 1.4 volts. So that suggests if the regulator's good, and we don't know that it is, but if it is, then there is something loading it down, but it's not a direct short. So it could be this chip. Kind of hard to determine if it's that chip. It'd be more of a process of elimination. It could still be this chip because it's got another feed going there. You see through here, through this resistor, 10K resistor, we go through this chip. So this chip could have some kind of problem. And do we feed anything else? So we determined this chip, these caps, And a resistor being open would not cause that, because that would provide less of a load, not more of a load. So in essence, we've either got something loading down this regulator or the regulator's bad. I think what I'm going to do is just a couple static checks around with the ohm meter in the circuit and see if anything jumps out as obviously awry. So we determined, excuse me, that this regulator was bad. Swapped it out with a brand new one from DigiKey. And this is our test. Let's see if we've got audio on both channels. Spins up, that's something. Watching the screen. Oh, it's a joy. Odd that that regulator was burned out, though. Those things are reasonably rugged to my understanding. And she's running about 100. Let's compare it with the one next to it. About 95. I think some testing is going to be in order. Oh, blast in the screen there. But at least we know the regulator was bad, needed to be swapped out. Question is, did something cause that to happen? So we'll run it for some tests and button it back up afterwards. But as of right now, it's a working machine. This over here, not this one over here, is the chip we just replaced. Excuse the camera movement. Trying to get it as the target. Well, there's the thermal signature. We can see these regulators are running a little warm. No, excuse me. I think it's these resistors that are running a little warm. Those should have probably been lifted up off the board. This guy's running hot. This guy here is running hot. Chips seem to be good. Nothing looks like it's scorching hot. Here, I'm now touching the DAC chips, the amplifier chips, the high definition chip, the signal processing chip. That's a look at the thermal structure. And I don't know if it'll show on here. I'm just curious what it would look like. Yeah, the channels look fairly even. More later. Back on my tiny bench with this beautiful Adcom GCD-750. What we're about to do is the dropout test on the Pierre test disc. Dropout test measures
the ability of a CD player to play when there is a physical gap on a disc, such as a smudge or a scratch, or just any defect. And let's just see how it does, and then we'll analyze it. "25 plays fine." Oh, looks like I accidentally skipped one, but 27 plays fine. The gaps get larger as we go. 28, fine. 29, fine. 30, fine. 31, fine. 32, fine. 33, oh, I hear a little tick. I'm take it back to 34. Get back to 33. So 33 represents 1.5 millimeter. When I tested it earlier, I had it up to 2.4 millimeters, and I wonder if it might be because I'm not level. I'm sitting on a towel, basically. Let me make a minor adjustment and return to this. Forgive me for that, but it seemed easier than starting and stopping. So let's just resume what we were doing. "33, hang on, I think I skipped 34. 34, yeah, I'm going to call it 33, which is 1.5 millimeter. Now the standard is track 27, which is 0.2 millimeter. And it is said that the greater the gap the CD player can play, the better the CD player. The way Pierre words it in his little booklet is, the better CD player is the one which corrects the largest defects. Well, I am very happy with 1.5 millimeters and beautiful sounding CD player. And that's what we will try next. How does it sound? And now for the grand finale. We will test it with music. Not just any music, royalty-free music. Because royalty-free music is the best music. This also is a good test of the unit playing CDR. Let's see how quickly she boots up and reads. Very nice. Mere moments. See how she sounds. Notice how quickly it changes when I press a different track. It is instantaneous. Beautiful. Push and play, wondering why nothing's happening. Well, that concludes this episode of My Tiny Bench with this beautiful Adcom GCD-750. And not just any Adcom GCD-750, this is Dan's Adcom. Be sure and watch next time for another edition of My Tiny Bench. Thanks for tuning in.